Happy Thanksgiving, everybody. In my world today, it's Thanksgiving, it's Thursday. I'm in my garage. This is Garage Math. My name is Mr. Henriksen, Mark Henriksen. Let's see, a little confusion today. TMI, I'm sure. I was supposed to go with my family to my mom's house, but then my mom texted me yesterday and asked me to go over there Friday for dinner. I thought she meant just me go over there Friday for dinner, because I do go over there sometimes to do some work around the house. Evidently, she meant the whole family to go over tomorrow. And then my son somehow found that out when he texted grandma this morning. So then I called her and she meant for the whole family. So that was a surprise to us. So basically, we have been home watching movies. I haven't changed out of this sweatshirt since yesterday. And I was working on this at the table. I had my phone and I saw the Cowboys beat the Kansas City Chiefs by 3. I do have a really good friend who probably just choked on his cranberry sauce because of that. So, Sniper, you're still on the hunt, I think. And let's see, I gotta wrap this up. Saw the Wicked second movie. I'm not going to throw it under the bus as much as it's been getting thrown under the bus. It's not really a sequel. They decided to take the musical and break it into 2 movies. Now, I can have an opinion about that, a little bit of a money grab, but the fact is, even in the musical, the first part has all the best songs, and it's also where you develop the characters. The second part wasn't necessarily a home run, but I think it was basically the material they had to work with. I thought they wrapped the story up great. I hope Elphaba and the Scarecrow wander off into that desert and live happily ever after. And then looks like Glinda is going to go on to do great things because she's sort of the boss. So I thought the whole thing was great. I love the first one. The second one is not a rewatchable. I don't think I'll watch it again. Doesn't mean that it was bad. I think they could have just made it all into one. But who am I? It gave me an excuse to go out and have some popcorn and have a good time. Okay, that's it. Here's what we're going to talk about today. We're going to talk about direct variation. Oh, I made a change to my studio. I moved over a little bit and I raised this up. I started to realize why when I get to the bottom was I crouching like this, and it was sort of awkward. So I moved this up. I do have lights right here because it's in the evening time. I don't even know what we're gonna have for Thanksgiving dinner. My wife found this recipe. It's that corn stuff you get when you go to Chevy's. They just give you that little scoop and you wish you had like 4 more scoops. It tastes exactly the same. And so I thought it was delicious. I think that's dinner. Okay, that's fine. Okay, so here's what we're gonna do. Oh, there's a light right there. And I don't know if it's bouncing off my glasses. We'll find out. All right, direct variation. There's a formula for this. It sort of is dipping your toe into linear equations, graphing system of equations. It gets a lot hairier than this. I think sometimes when we throw the formula y equals kx at you, which I'm going to do, it sounds way more confusing than it is. So I'm going to try to do things the way that I like to learn to make things sound not as difficult as they are. Just a little bit, I have an example here that's just not particularly confusing. So hopefully, and then I am going to get to one confusing part at the end. So I think I'm going to have you. The last part, I'm going to dip my toe in it. And if you don't understand it, that's okay. You're still going to be just fine. All right, basically, direct variation. This thing is just the rules right here. So I think you should write this down. And then we're going to work through some problems. It's not super worky type problems. It's more logic. To be directly variated, sure. Here's the 3 things that have to happen. It has to be a linear equation. That's a fancy way of saying it has to be a straight line. So when you graph the points, if it's a straight line, that's check 1, okay? Check 2, it has to pass through the origin. Your line has to go through 0, 0. Why? Let's not worry about that for right now. If it doesn't go through 0, 0, it's not a direct variation, okay? And the final one is it has to be a proportional relationship. Basically, it's called a constant ratio. If you take your x and your y and you reduce them, or even reduce them, it will all reduce to the same. I'm going to show you some examples of all of these. So don't freak out. Just understand. Has to be a line, check. Has to go through the origin, check. They all have to reduce to the same number, check. If you have those three things, you have direct variation, okay? That's it. Oh, here's the formula. Write that down. Y equals kx. Y equals kx. Okay, so we're going to do a problem, and you're going to understand what this means. Basically, the y and the x, they have a relationship. Okay, they're related. If this changes, this changes. Okay, and the k is basically the slope. It's almost like y equals mx plus b, but you're not ready for that yet. I think that's more 8th grade. K is the constant. Think of it as the slope. It never changes, okay? So if you're gonna wash dogs and you get $2 per dog, the number of dogs can change, the number of total profit you make can change. What will never change is the 2, okay? So that's basically what the K is. That's a constant. It doesn't change, okay? All right. Ooh. Oh, man. Okay, so here we go. What I have right here is I made a problem and I try to use it for something that we understand. Kings won 2 in a row, then they lost. That's okay. Warriors lost yesterday too. So here's an equation. Y equals 2x. Y equals 2x. And the x represents baskets. Whenever you have these equations, you always have to label what the x and the y are. Okay? The X is the baskets. Now, this is old school basketball. Before they had a 3-point line, they used to just to have 2-pointers. So if you shot it from 30 feet away or a slam dunk, you got 2 points. So for this, we're not talking free throws, and we're not talking 3-pointers. For every basket, you get 2 points. For every basket. So that could change, that could change. Y is the total points, okay? So this right here is an XY table. So what we're gonna have to figure out is when we plug in this, remember the X is the baskets. So if you make one basket, how many points do you have total? 2, okay? Because 2 times 1 is 2. You're gonna see and you're gonna catch a pattern really quick. If you make 2 baskets, 2, 4, you're gonna get 4 points, okay? 3 baskets is 6 points. 4 baskets, woohoo! 8 points. I officiated a basketball game yesterday because I do high school basketball in my spare time. I won't tell you who the 2 teams are, but one of the teams won by 81 points, and they were basically doing a slam dunk contest throughout the whole game. The dunks are pretty awesome. 2 of them were the best dunks I've ever seen in high school in 17 years of doing this. And 0, you didn't score. Boo! Then you have 0 points. Okay, so we're gonna ask if this is direct variation. So let's go through the rules. Is it going to be a straight line when we plot them? Is it going to go through 0, 0? And do we have constant ratios? Okay, so let's go ahead and graph this. So X is 1. I have baskets right here. X is 1. Y is 2. Okay, for every 1 basket, you get 2 points. For 2 baskets, you get 4 points. For 3 baskets, you get 6 points. For 4 baskets, you get 8 points. Now, if I had a ruler and I was using graph paper, ooh, that's not bad. That's not bad for a scraph. Okay, so we have a straight line, sort of, it should be. We go through 0, 0. Ooh, those are 2 of the checkpoints. What's the 3rd checkpoint? The 3rd checkpoint is, do these reduce to the same? So let's imagine like X and Y. So let's just pretend these are fractions. 1 over 2 is 1/2. 2 over 4 is 1/2. 3 over 6 is 1/2. And 4 over 8 is 1/2, okay? And we're not gonna use these actually. 4 over 8 is 1/2, okay? So the 4 times 2, 3 times 2, 2 times 2, 1 times 2. There is a correlation. Okay, so this is direct variation. These have a relationship. The more points, the more baskets, the more points. Okay, it satisfies the 3 rules. Cool. All right, let's move on. Now, these ones we're not going to graph. We're just going to use our brain, and they're going to give us a set of numbers, and we're going to say, okay, is there direct variation? Well, we're not going to graph, and we're not going to see if it's going to go through 0, 0, kind of. We're going to use the strategy of, do they reduce to the same? Do we see a ratio? okay? So this one, again, you can pretend and make up a word problem. So I'll say, for every 3 French fries I eat, I like to have 9. That's not a really good example. I should have had one ready to go. Okay, for every 3 hamburgers I buy, I'm gonna buy 9 cheeseburgers because I'm gonna have a party, all right? So 3 to 9, 3 times 3 is 9, 8 times 3 is 24, 4 times 3 is 12, 5 times 3 is 15. This reduces 5 over 15 is a third, 4 over 12 is a third, 8 over 24 is a third, 3 over 9 is 1/3. So yes, this is yes, okay? That is yes, all right? Let's try this one, okay? So I did a thing a while ago about like a fruit salad. If you have this many strawberries and you have this many bananas, you have to keep the ratio the same. So think of it in that terms, okay? So we can use this. I want you to think, is this yes or no, okay? Is this direct variation? I bet you're going to say no, because they don't reduce to the same. 2 over 2 is 1. 4 over 3 is not 1. 6 over 4 is a half. 1.5, and 8 over 5 is 8 over 5. That's not even close. So this one is no, okay? So we could use our fruit salad example. Let's say X is strawberries and Y is bananas. 2 to 2 means it's the same. If you have 2 strawberries, you better have 2 bananas. Well, we're already off, because now we have 4 strawberries and 3 bananas, and our ratio no longer is the same. So that's a no. That's not direct variation. Okay, let's try this one. 1 strawberry to 4 bananas. Is that the same as 2 strawberries to 8 bananas? It is, because that reduces to 1 over 4. Is it the same as 3 strawberries to 12 bananas? It is, because that reduces to 1 over 4. We're looking good. 1/4, 1/4, 1/4. What about 4 strawberries to 15 bananas? What's the problem? It's close. We don't have enough bananas, okay? Because 3 times 4 is 12, 2 times 4 is 8, 1 times 4 is 4 times 4, that should be 16. So this one is no, okay? It's so close, but it's not, okay? Cool. All right. Last thing. This one is the trickiest part of this whole video. So what we're going to talk about is y equals kx. Like, that's the formula. Y equals kx. We already talked about the y and the x. Okay? So the y and the x, like we talked about, could be points and it could be baskets. So, but it has to look like this. So just to make it probably as least confusing as possible, there can't be a plus or a minus over here. So for example, these are all the yeses. That is direct variation because it's y equals something x, y equals something x, and y equals, there is a something, there's really a 1 here, okay? So this is yes. These are all no. And the reason why they're no is because they have other stuff here. And when you get to algebra and you get a little bit beyond this lesson, this will make more sense to you because you can graph those, okay? They're just not constant variation, okay? Direct variation. So if you got stuff at the end, stuff at the end, stuff at the end, it's no. Why? It just isn't, okay? All right, so last 2 things, and then we're going to call it a day. So basically, to get it to look like this, it's called solving for y. That's going to be a real big deal when you get into y equals mx plus b, which I don't think you're there yet. So we have to solve for y. Solve for y. We're going to use a little bit of algebraic skills. So if I have to solve for y for this problem, I'm going to go -1, -1. Okay, so that cancels. So y equals 2x minus 1. That is solving for y. So then you got to look, which one is this? Is it the no or is it the yes? It's this one's the no. Okay, so that is not direct variation. Okay, this one, solve for y. Use all of your algebraic skills. We've done this in one-step equations. It's another video. Solve for y, solve for y. So you have to get the y by itself. So what you do to get rid of the 1/3 is you multiply it by its flippy flip. So if you multiply this by its flippy flip, okay, that becomes 1. So that becomes 1y. And then you multiply this by 3, which is 3x, okay? That's 3x. So does this look like this or does this look like that? Ooh, this would be 3-pointers. For every basket you make, you get 3 points only if you shoot 3-pointers. Okay? So this one's yes, this one's no. If that one sort of made you like, what? You'll be okay. Don't worry about it too much. You can probably find another video or ask a friend. So that's it, direct variation. It's kind of, the slope is the consistent, it's common ratios, equal ratios, and that's all I have. Okay, I'm gonna go in and eat some corn pudding, I guess. That would be my dinner. And I will check everybody out down the road. Peace.